Welcome, curious minds. Today, we're embarking on a deep dive into something truly fundamental to our digital lives: data. We're going to pull back the curtain on the internet's, staggering economic value, uncover where its power is currently concentrated, and expose the surprising inefficiencies and hidden costs that are kind of baked into its very foundation.
It's a profound shift, really. The internet began with these dreams of decentralization. Yet today, much of its economic power has really funneled into the hands of just a few dominant platforms. Understanding this landscape is crucial because it highlights the urgent need and, the incredible potential of an emerging alternative we'll be exploring, Filecoin.
That's right. Our mission today is to cut through the noise, pinpoint the most impactful insights, and reveal how this innovative technology isn't just about storing data differently. It's about a fundamental reimagining of how value is created, captured, and distributed across the entire digital economy. For you, our listener, this means understanding everything from how it impacts your personal privacy to, potentially revolutionizing global healthcare. So let's begin this exploration. When we talk about the internet's economic value, we're venturing into truly colossal numbers. What's the sheer scale of this digital empire that surrounds us?
It's huge. As of 2025, the total market capitalization of internet-related companies globally already tops $25 trillion. And they're generating more than $5 trillion in annual revenue. This isn't just about a handful of tech giants either.
Right, so we're looking far beyond the familiar names then. Who else comprises this incredible $25 trillion pie?
Precisely. This digital empire spans colossal sectors. You've got e-commerce platforms like Alibaba and Shopify, the entire landscape of financial technology providers, the vast realm of cloud-based enterprise software, digital entertainment, and the burgeoning sharing economy. But here's where it gets truly revealing. A significant portion of this value is heavily concentrated geographically. North American companies, for instance, command about 65% of the market capitalization of internet firms. Europe, just 8%. This kind of concentration carries real geopolitical weight, It's driving legislative efforts like the EU's Digital Services Act.
Fascinating. So what does this concentrated power mean for you, the typical user, or maybe a growing business? How do these colossal companies actually monetize our digital interactions, and what are the hidden costs we rarely see?
Well, the dominant revenue streams are digital advertising and cloud services. Digital advertising alone hit $790 billion in 2024. This model often relies on, extensive data collection, what some people call surveillance capitalism. Users essentially pay with their attention and personal information rather than direct currency. Services get optimized to maximize engagement, sometimes, at the expense of user well-being, and the tracking is pervasive. The average website now embeds 74 third-party trackers. That's a jump from 52 just back in 2020.
74? That's an astonishing number of hidden eyes tracking our every click. And what about the cloud services, the ones that underpin so much of the modern internet?
Yes, cloud computing. It's a $1 trillion market in 2025, with projections to nearly triple, maybe to $2.9 trillion by 2030. Now, it offers incredible flexibility and scalability, no doubt. But the model is characterized by high fixed costs for providers and very low marginal costs. This creates immense economies of scale that inherently favor the largest players. And then there's the less visible data broker industry, a $250 billion market, quietly operating behind the scenes, capturing significant value from data without compensating the individuals who actually generated it.
Given all of that, what are the inherent flaws and sort of economic imbalances that have emerged from this centralized Web 2 architecture?
We see substantial costs from data breaches. The global average cost reached $4.88 million in 2024. That's per breach. And despite a staggering $219 billion spent annually on cybersecurity, breaches persist. It really suggests a fundamental vulnerability in the centralized model itself. There's also enormous redundancy. In financial services alone, an estimated $150 billion annually is wasted on duplicated data storage. Just gone. And then there's what some call the innovation tax of centralization. Developers often pay 15-30% fees to platforms, they encounter barriers to data access, and face steep costs for scaling up.
So it's not just about a few companies accumulating wealth. It sounds like it's about deep systemic inefficiencies that ripple out to impact everyone, even the environment.
Precisely. Large data centers consumed about 2% of global electricity in 2025. That's projected to reach 3-4% by 2030, contributing 250 million metric tons of CO2 equivalent. Beyond that, the power asymmetries are striking. Platforms can unilaterally increase fees. Amazon sellers, for example, often pay 34% of their revenue in fees. They can change rules without warning and even launch competing products against their own users. And for platform workers, Jobs often mean 10–30% less pay with something like 2.5 times higher income volatility. These issues clearly highlight the urgent need for a new architectural paradigm.
So, if centralization is the core problem, what's the answer? And how does Filecoin actually propose to be that fundamental architectural shift?
The answer truly lies in decentralization. Filecoin is built upon the Interplanetary File System, or IPFS, which represents a radical departure from traditional location-based addressing, where you find data by where it resides, like a specific server URL. Instead, IPFS uses content address storage, meaning you find data by what it is via unique cryptographic hashes.
Okay, so if I understand content address storage correctly, does that mean any tiny alteration to the data would fundamentally change its address, making it inherently verifiable? That seems incredibly powerful for ensuring data integrity.
You've hit on the core insight there. That's exactly right. It ensures inherent data integrity.
Yeah.
And it enables remarkable efficiencies like deduplication, where common blocks of data are stored only once, even if they appear across countless different files. Think of the savings. Filecoin then builds on top of IPFS by adding powerful economic incentives, effectively creating a true open market for storage.
So it's not just about sharing files more efficiently, it's about building a robust system that actually incentivizes reliable, verifiable data storage. How does that economic engine work?
Filecoin uses its native cryptocurrency, FIL, to power a global marketplace. Clients pay storage providers, often called miners, to store data. The core innovation here lies in cryptographic proofs. Proof of replication ensures a provider has uniquely stored your data, proving it's not just a lazy copy. And proof of spacetime proves they've continuously stored that data over the agreed-upon time, like constantly proving it's still there. They've even introduced a new proof of data possession in 2025, specifically for data that needs to be instantly accessible, or hot data.
And what about the security and scaling of this whole decentralized system? How does it manage to avoid the, infamous energy consumption pitfalls we see with some traditional blockchains?
That's a great question. Filecoin's expected consensus mechanism cleverly ties block production directly to useful storage work. This means the network security isn't based on burning energy through intensive computations, like proof of work. Instead, it's based on the very act of providing storage. It aligns economic incentives directly with the network's core purpose. And the network has proven incredibly robust, no successful attacks on its consensus mechanism since its launch in 2020.
That's quite an impressive track record. What other key developments make Filecoin seem ready for a much bigger role in the digital landscape?
Well, a major leap forward happened in 2023 with the introduction of the Filecoin Virtual Machine, or FVM. This essentially gives the network a brain, right? It allows developers to deploy smart contracts. These are self-executing agreements stored on the blockchain that can interact directly with the stored data. This opens up entirely new use cases like data DAOs, where communities can collectively own and govern datasets. Very powerful. Plus, there have been massive scaling improvements like Filecoin Fast Finality in 2024. This dramatically reduced transaction confirmation times from 7.5 hours down to just minutes. That paves the way for real-time financial transactions and much more interactive applications.
It truly sounds like they're building a comprehensive ecosystem, not just a storage layer. What about bridging this decentralized world with the traditional cloud infrastructure that so many businesses already rely on?
Good point. Filecoin Web Services, introduced in 2024, provides S3-compatible APIs. This is the potential game changer because it allows applications designed for Amazon S3, a very common standard, to work pretty much seamlessly with Filecoin, with minimal, if any, modifications. This enables flexible hybrid storage models. You might use Filecoin for your, say, warm and cold data less frequently accessed stuff while keeping your most active hot data on the traditional cloud. We're also seeing explosive growth in storage capacity. It went from 0 to over 20 exabytes in less than 5 years. And projections are talking about zettabyte scale within the next decade. The scale is just immense.
Zettabyte scale. Wow. And looking even further down the road beyond just storing things, what's the ultimate vision for Filecoin?
The roadmap includes something called compute over data. This is foundational for advanced AI, scientific computing, complex data analytics. It means you can perform computations on stored data without having to retrieve it first. This preserves data locality, enhances privacy, and saves on bandwidth. And with something called interplanetary consensus, Filecoin aims to be a crucial interoperable infrastructure layer across the entire Web3 ecosystem, connecting everything.
Okay, let's switch gears slightly. From a purely economic standpoint, how does Filecoin actually stack up against the cloud giants? Let's talk dollars and cents.
Right, the economics. This is where the story gets incredibly compelling. Traditional cloud storage providers typically maintain gross margins of maybe 60-70%. They invest massively in data centers. The top three spent over $140 billion on capital expenditures in 2024 alone, and then they pass those costs, plus a hefty margin, onto you. And especially noteworthy are their data transfer fees, or egress fees. These can make it prohibitively expensive to move your own data out, creating a really powerful vendor lock-in.
Yeah, that certainly sounds like a design trap. What's Filecoin's fundamental difference in approach that changes the cost structure?
Filecoin's decentralized architecture fundamentally re-engineers the cost structure. It's built differently from the ground up. Storage providers can repurpose existing hardware. They can locate their operations in areas with lower electricity and real estate costs anywhere with an internet connection, basically. And crucially, that content addressing we talked about, it inherently eliminates redundant copies of data across the network. All of this allows Filecoin to offer storage at dramatically lower costs.
Can you give us some hard numbers on just how much cheaper we're talking? Ballpark figures.
Absolutely. As of mid-2025, standard storage on Filecoin is approximately 94% cheaper than average traditional cloud storage. 94%. For cold storage, the kind you don't need instantly, the savings are around 90%. Even retrieval fees, getting your data back, are typically 80-90% less.
Okay, let's try and crystallize this with a real-world scenario. Imagine a company managing large volumes of data, say, over 3 years.
Okay, let's take a scenario with significant cold data and high egress requirements, meaning they need to pull data out often. A 3-year total cost of ownership on a traditional cloud could easily exceed $1.6 million. On Filecoin, that same scenario could cost just $117,600. That represents a staggering 93% savings. Even for warmer data with moderate egress, maybe data you need a bit more often, we're still looking at impressive 77% savings.
That's a truly massive difference. And what's particularly striking here is that this isn't just like a temporary promotional discount, is it? This is structural.
That's entirely correct. It's structural. While traditional cloud prices have seen their decline slow down to a modest 3-4% annually, Filecoin's average price for standard storage has consistently declined by 25-37% annually from 2021 to 2025. Projections actually suggest Filecoin's cost advantage will likely increase, maybe reaching 98% cheaper by 2030 as the network continues to optimize and scale its operations globally.
So if we connect this back to the bigger picture, what does this ultimately mean for who actually captures the value in our digital economy? Where does the money flow?
Right. In the traditional cloud model, roughly 65% of your spending goes directly to the cloud provider's profits. In Filecoin, the value flows much more broadly, much more distributedly. Storage providers earn rewards and fees for their service. Token holders, people holding FIL, potentially benefit from the network's utility and growth. Developers can build innovative applications on top without huge platform fees. And crucially, content creators could potentially earn directly from their data through new mechanisms like those data DAOs we mentioned. It's designed for a much more equitable distribution of value.
That brings us to a critical point. How do the established cloud players typically react? How are they likely to respond to this kind of profound disruption?
Well, traditional providers will undoubtedly respond. They won't just sit still. They might cut prices somewhat, though their fixed cost structures, those massive data centers limit how far they can realistically go. They'll likely emphasize features or services Filecoin might currently lack, or perhaps focus on enterprise support packages. Or they might explore hybrid integrations. We're already seeing some major cloud providers quietly exploring integrations with decentralized storage networks. It's early days, but it's happening. So while competition will remain intense, Filecoin's structural cost advantages are, well, pretty formidable.
And looking ahead, what's the realistic potential market share for Filecoin in this highly competitive space? Can it really take a significant slice?
Even in a fairly conservative scenario, models suggest Filecoin could capture maybe 8% of the global cloud storage market by 2030. That would represent a substantial $20.5 billion market share. In a more aggressive, optimistic scenario, it could reach as high as 30%. Either way, this truly positions Filecoin as a major disruptive force in the digital economy.
Okay, moving beyond the pure economics, there's this deeper, more personal conversation about who truly owns and controls our data. We've heard this term thrown around a lot, data sovereignty. What's the core crisis we're facing today, and how does Filecoin directly tackle it?
The crisis is indeed multifaceted. For individuals, there's a systematic erosion of data rights. Data collection is often incredibly opaque. Think about it. The average mobile app shares data with 6 third parties. And a huge majority, like 78% of consumers, don't even understand how their data is used for automated decisions that directly impact their lives. loans, job applications, things like that. Control mechanisms are limited, often hidden behind deliberately acting dark patterns in user interfaces, making it hard to opt out. And there's this massive asymmetric value capture. In 2024, the average American consumer generated maybe $2,000 worth of data value annually, but received less than $5 in direct compensation. It's wildly unbalanced.
Wow. So we're essentially giving away incredibly valuable personal assets without truly knowing it, or certainly without fair compensation.
Yeah.
What about the challenges this presents for organizations, for businesses?
Organizations face severe vendor lock-in, largely due to those high egress fees we discussed, and also proprietary data formats that make switching providers difficult and costly. A 2025 survey found 67% of enterprises felt highly dependent on their primary cloud provider. Trapped, essentially. They also have frustratingly limited visibility into how their data is actually stored and used by these cloud providers, which can stifle their own innovation and autonomy. They don't fully control their own assets.
And at the national level, we're seeing concerns about data control tied to broader geopolitical dynamics, right?
Absolutely. At the national level, concerns about digital colonialism are definitely growing. That's where foreign corporations control critical digital infrastructure and extract value from a nation's data. This has led to over 80 countries implementing data localization laws by 2025, demanding data be stored within their own borders. Filecoin's framework directly addresses this by providing cryptographic guarantees of data integrity. It allows you to mathematically prove your data hasn't been tampered with wherever it's stored. It also offers fine-grained access controls through encryption and smart contracts, allowing much more control.
What's particularly powerful, it seems, is that it also includes these self-sovereign identity tools. That sounds incredibly empowering for individuals and organizations.
They really are. Using things like decentralized identifiers, or DAOs, and verifiable credentials, individuals and organizations can actually control their digital identities without relying on a centralized authority like Google or Facebook or even a government in some cases. And with the Filecoin virtual machine, you can create programmable data policies using smart contracts. These can precisely specify who can access data, how it can be used for how long, and even how value generated from it is automatically distributed. Or they can automate compliance with complex regulations like GDPR or APIA.
This sounds great in theory. Can we see this in action with some concrete examples? Where is this actually being used?
Definitely. Consider patient-controlled health records. One pilot implementation using these principles saw 94% of patients report feeling more in control of their own health information. That's huge. Unnecessary duplicate medical tests were reduced by 37% because doctors had verified access to previous results, and patients who opted into sharing anonymized data for research actually earned an average of $215 annually. They got compensated for their data's value. Another compelling example is creator-owned content distribution. A protocol using Filecoin for storing videos or music-reported creators seeing an average 35% increase in net revenue because they bypass middlemen. And they saw a remarkable 60% reduction in piracy because the content is tracked and verified differently.
Those are really compelling real-world impacts. What about for larger entities, maybe corporations or even nations?
Yes, it scales up too. In enterprise data management, one firm implemented a Filecoin-based data mesh architecture. They saw a 64% reduction in the time it took to access data across different company departments. Much more efficient. A Southeast Asian nation implemented a Filecoin-based sovereign cloud strategy. This resulted in 73% of their critical government data being stored domestically under their control and led to a 42% reduction in storage costs. We even see it being used for indigenous knowledge data trusts. This helps communities manage their vital cultural heritage collections digitally and negotiate licensing agreements that truly respect their cultural protocols and ensure fair benefit sharing.
Okay, let's pivot again. When we talk about the future of AI, especially the big concepts like artificial general intelligence, AGI, and superintelligence data becomes even more absolutely foundational. How does Filecoin fit into that incredibly complex, data-hungry picture?
Well, the data challenges for advanced AI are just immense. AGI, for instance, is predicted to require 100 to maybe 1,000 times more data than even today's largest language models. And across multiple modalities, text, images, video, sensor data, we are talking about easily needing exabyte-scale datasets, maybe zettabyte-scale eventually. And as AI systems become more autonomous, the provenance where the data came from and the integrity knowing it hasn't been messed with their training data become absolutely critical for ensuring safety, ethical alignment, and just avoiding dangerous unintended consequences.
Right. So it's not just about the sheer volume, which is staggering in itself. It's about verifiable, trustworthy data being fed into these powerful systems.
Exactly. Content addressing, that core IPFS feature, provides cryptographic guarantees that training data is immutable. Once it's hashed, you know if it changes. And it means an AI model's entire provenance, what data it learned from, can be verified. You can trace its education, so to speak. This directly addresses a critical vulnerability in current AI development, where data poisoning or manipulation is a real risk. It also offers significant deduplication benefits. Because AI models often train on overlapping data sets, this could potentially reduce storage requirements for the entire AI industry by maybe 30–40%.
This opens up an important question then. How does Filecoin actually enable better AI safety and maybe even new economic models for data used in AI?
Well, Filecoin enables transparent training verification. Organizations can make provable claims about precisely what data was used, or importantly wasn't used, to train their models. Think about bias audits, for example. It also supports decentralized safety monitoring with tamper-evident logs of AI behavior stored on Filecoin. You can track what the AI does and know the log is secure. Economically, it can enable fair compensation for training data. You could imagine automated royalties flowing directly back to the original data creators via smart contracts whenever their data is used to train a model. And it facilitates those compute over data markets we touched on earlier. The computation moves to the data rather than the other way around, which fundamentally preserves data sovereignty and privacy, especially important for sensitive training data.
What's fascinating here is how this thinking applies beyond purely digital AI, extending into physical systems like robotics and embodied AI. That seems like a whole other level of data challenge.
It really is. Robotic systems, especially autonomous ones, generate massive volumes of multimodal sensor data. An autonomous vehicle, for example, can generate something like 40 terabytes of data per day. They need storage that can handle both real-time data streams and historical data access across highly distributed environments, from sensors on the edge device itself to local hubs to the cloud. Filecoin's hierarchical storage capabilities and its ability to provide verifiable sensor data integrity are potentially perfectly suited here. You need to trust the sensor data for safety. We're already seeing early signs, like a consortium of autonomous vehicle manufacturers exploring Filecoin for an AV data commons to collaboratively share verified sensor data for accelerated safety research and development without giving up control.
This leads us nicely into one of the most exciting and perhaps most complex applications we've discussed, potentially revolutionizing healthcare financing and delivery. This seems to bring together decentralized tech, digital health, and finance in a really powerful, maybe even radical way. What's the overarching idea here?
We're talking about a potential paradigm shift, yes. Leveraging health data, decentralized autonomous organizations, or DAOs, powered by digital twin technology, and using Filecoin as the storage layer to enable something called health bonds. These are envisioned as groundbreaking financial instruments that would directly link investment returns to demonstrable improvements in population health outcomes.
So, hold on. Instead of just investing in a country's economic growth, like GDP, you're suggesting investors could invest directly in the health and well-being of its citizens and get returns based on that.
Precisely. That's the core concept. It builds upon existing ideas like social impact bonds, or SIBs, and development impact bonds, DIBs, where investors get paid back by governments or donors if predefined social outcomes are achieved. But traditional SIBs have often struggled with consistent, reliable, verifiable measurement of those outcomes. It's hard to prove success accurately. This is where digital twin technology could become truly transformative.
Okay, tell us more about these digital twins in a healthcare context. What are they exactly?
So digital twins in healthcare are essentially virtual dynamic replicas of individual patients or specific populations, or even entire health systems like a hospital network. They are continuously updated with real-time data from wearables, from IoT sensors, electronic health records, genomic data, etc. Imagine individual digital patient twins where doctors could virtually test thousands of drug interactions to find the optimal personalized treatment before giving it to the real patient. Or population digital twins that can accurately model how a disease might spread or how a public health policy change might impact different demographics. They offer unprecedented precision in health monitoring and outcome prediction.
Wow. And when you combine these incredibly precise digital twins with DAOs and Filecoin, what new possibilities emerge? What does that unlock?
Well, health data DAOs could securely manage the vast quantities of sensitive health information needed for these twins. They can facilitate privacy-preserving analytics across these datasets and govern the rules for creating and updating the digital health twins. Filecoin, in turn, provides the secure, verifiable, and tamper-proof storage bedrock for all that underlying data. This combination enables unparalleled real-time outcome measurement and verification, which is absolutely essential for the performance-linked payout structure of these proposed health bonds. You need proof the health outcome is achieved.
Okay, but this raises a critical question. How does Filecoin handle the absolutely massive scale and the profoundly sensitive nature of personal health data while ensuring ironclad privacy? That seems like a huge hurdle.
It's a crucial point. Filecoin's verifiable storage, with its continuous integrity checking proofs, happen roughly every 24 hours, ensures that the digital twin data underlying bond performance calculations hasn't been tampered with. You can trust the metrics. Content addressing to IPFS ensures seamless, consistent data sharing and version control across potentially very complex digital twin systems involving many data sources. And crucially, Filecoin's cryptographic security foundation supports advanced privacy-preserving computation techniques. You don't necessarily need to expose the raw data.
What are some of those cutting-edge privacy techniques you're referring to? How do they work?
We're talking about technologies like zero-knowledge proofs, or ZKPs. These can mathematically demonstrate, for instance, that a population achieves specific health targets, like a certain vaccination rate or a reduction in diabetes incidence, without revealing any individual patient's data. It's quite remarkable. There's also differential privacy, which intelligently adds statistical noise to data sets before analysis to guarantee individual privacy while still allowing accurate population-level health analytics. And then there's homomorphic encryption, which allows you to perform computations directly on encrypted health data without ever having to decrypt it. The data stays protected throughout the analysis. These kinds of capabilities are absolutely essential for navigating the complex web of diverse global privacy regulations like GDPR in Europe or HIPAA in the US.
So, stepping back, what does the potential economic scale look like for this entire new market segment? Is this niche, or could it be substantial?
It looks potentially very substantial. The global digital health market is already projected to reach nearly $660 billion by 2025. And digital twin technologies, specifically within healthcare, are expected to hit maybe $73.5 billion by 2027. You combine that with the overall $9.8 trillion global healthcare expenditure, and you create an absolutely massive addressable market for these kinds of digital twin-enhanced health bonds.
Can you give us maybe a more concrete hypothetical example of a health bond and its potential impact?
Certainly. Let's consider a hypothetical national cardiovascular health bond in Estonia. Estonia's advanced digital infrastructure makes it a plausible testbed. You can structure, say, a 10-year, $500 million bond aiming to achieve a 20% reduction in cardiovascular mortality within their population. Financial modeling based on prevention effectiveness suggests this could offer annual returns of perhaps 4 or 5% for investors if the target is met. But the real impact: it could potentially prevent approximately 2,600 cardiovascular deaths and generate an estimated $400–600 million in healthcare cost savings for the country over the decade. A double win.
That's incredible, linking financial return directly to saving lives and saving healthcare costs. And could this scale beyond a single country?
Absolutely. You could envision something like a global pandemic preparedness health bond, maybe a 15-year, $10 billion issuance, with returns tied to measurable improvements in global surveillance capabilities, diagnostic capacity, or vaccine distribution infrastructure across multiple countries. This could use international digital twin systems built on verifiable data stores like Filecoin to monitor disease patterns and health system capacity in real time across borders. The economic impact could be preventing trillions of dollars in losses from future pandemics, far outweighing the bond cost, and potentially spurring entirely new industries focused on global health security technology and services.
So if we really step back and absorb all this, Filecoin isn't just about storing files for your latest app or website more cheaply. It's genuinely laying the groundwork for potentially completely new economic models for health, for data, for AI, and beyond.
Exactly. Filecoin's combination of verifiable storage, its support for privacy-preserving computation, and its inherent global accessibility creates a compelling value proposition that traditional centralized cloud services simply cannot easily match for these kinds of use cases. It's uniquely positioned, potentially, to capture significant value from this transformative market. It's truly about architecting a future where capital markets can actively, verifiably contribute to a healthier, more resilient world.
Okay, Filecoin has clearly built some impressive technology and demonstrated powerful use cases across a really diverse range of industries. What does the road ahead actually look like? What's the path to broader adoption and maybe even potential market dominance?
Well, Filecoin has indeed achieved significant scale already. We mentioned the 25 exabytes of total storage capacity and over 8.5 exabytes of actual client data stored. That data is distributed across providers in about 35 countries. Adoption is currently highest among sort of Web3 native organizations, content creators, research institutions, groups already comfortable with decentralization. But it's definitely still early days for mainstream enterprise adoption.
So what are the key drivers then? What factors will likely propel its growth in the coming years?
Several key factors seem to be aligning. Firstly, the proliferation of data sovereignty regulations globally is creating a strong inherent demand for verifiable data control and localization options. Businesses need solutions here. Secondly, the exponential growth in AI data requirements, projected at something like a 55% compound annual growth rate through 2030, presents another massive opportunity. AI needs vast, verifiable data. And of course, Filecoin's significant cost advantages, which we detailed often 90% lower than traditional cloud for cold storage, become increasingly compelling as the sheer volume of data companies need to manage continues to explode. Cost pressure is real.
That sounds like a strong set of tailwinds pushing it forward. Yet despite all these advantages, there must still be significant barriers or challenges to overcome, correct? It can't be all smooth sailing.
Oh yes, absolutely. There are definitely hurdles. Technical complexity remains a challenge, particularly for smaller businesses or enterprises without dedicated Web3 expertise. It's still newer technology. Retrieval performance, while constantly improving, still needs to fully match the instant speeds of centralized alternatives for all types of use cases, especially very hot data. And enterprises have high expectations. They require comprehensive service level agreements, SLAs, clear regulatory compliance certifications like SOC2, and seamless integration with their existing IT infrastructure and workflows. Plus, honestly, general awareness and understanding outside the immediate Web3 community is still relatively low. Many potential users just haven't heard of it or don't grasp what it offers yet.
Okay, so given those challenges, what's the strategic roadmap? How does the Filecoin ecosystem plan to tackle these issues head-on and unlock that broader adoption?
It involves several parallel tracks. Continuous performance optimization is key. The goal is aiming for performance parity with centralized cloud for, say, 80% of typical use cases within the next few years. It also means deliberately building out more enterprise-specific features, things like enhanced granular access control systems, robust compliance reporting tools, easier management interfaces. Crucially, fostering the application layer growth is vital. That means actively supporting developers building storage-intensive projects on Filecoin, encouraging diversification among the network of storage providers globally, and investing massively in education, documentation, and training across the entire ecosystem, making it easier to build and use.
And from a pure market penetration or go-to-market perspective, how do they reach those enterprise customers?
That involves developing more vertical-specific solutions, tailored offerings for critical sectors like healthcare, media and entertainment, finance, and government, addressing their unique pain points. Strategic partnerships will be absolutely vital, collaborating with major technology platforms, cloud providers, maybe hybrid models, system integrators, channel partners, and key industry consortia to accelerate adoption and build trust. We're talking about things like structured enterprise adoption programs with dedicated technical support, proof of concept funding, and tailored regional growth strategies to meet local market needs and regulations.
So if we pull all that together and look ahead to, say, 2030, what does this all mean in terms of potential market share? What's a realistic outcome?
Well, based on current trends and assuming successful execution of these strategic initiatives, in what you might call an accelerated adoption scenario, Filecoin could realistically capture maybe 8-10% of the global cloud storage market by 2030. This would likely be fueled by successful adoption within key enterprise segments, significant uptake for AI data storage use cases, and the fruition of major strategic partnerships currently in development.
But as with any ambitious project, no grand vision comes without its own set of risks. What are the major hurdles or potential pitfalls Filecoin faces on this journey to potentially reshape a significant part of the digital landscape?
There are certainly several significant risks to manage. Technical risks always exist, including potential protocol security vulnerabilities that might emerge, and the immense ongoing challenge of ensuring true scalability and performance reliability as the network grows towards zettabyte capacity. Economically, the price volatility of the F-file token itself can be a concern for mainstream enterprise adoption, as businesses prefer predictable costs. There's also the potential for minor centralization. If too few large providers dominate storage, it could undermine the decentralization benefits. Regulatory risks are ever present in the crypto space. Unfavorable cryptocurrency regulations in key jurisdictions or legal ambiguity around liability for user-generated content stored on a decentralized network could pose challenges. And finally, governance risks. Like any large decentralized project, there's the potential for community disagreements or decision-making deadlock that could slow down progress. Careful, transparent, and adaptive governance is crucial. Proactive engagement, continuous security, auditing, and flexible design are really the key mitigation strategies here.
Wow. What an incredible, wide-ranging deep dive. We've really peeled back the layers of the current internet's economic landscape, haven't we? We've revealed those hidden inefficiencies and power imbalances that are just baked into its centralized architecture. And then we thoroughly explored how Filecoin is offering not just, a technical alternative for storage, but potentially a truly fundamental paradigm shift in how we handle data.
We really have. We've seen how Filecoin's unique blend, that combination of verifiable storage, cryptographic proofs, and built-in economic incentives directly addresses critical challenges. Everything from ensuring digital sovereignty and combating digital colonialism to meeting the absolutely massive future data needs of artificial general intelligence and even robotics. And the potential for dramatic cost savings is clearly enormous, as is the underlying promise of a genuinely more equitable distribution of the value generated from data.
And perhaps most excitingly, at least for me, was exploring how Filecoin could underpin radical new models in areas like healthcare. Thinking about those health data DAOs and health bonds. That idea of transforming how we fund and deliver health by linking investment returns directly to measurable improvements in population well-being. That's potentially world-changing stuff.
It really highlights that Filecoin aims to be far more than just a cheaper storage network, right? It's positioning itself as a foundational cornerstone of a more open, equitable, and importantly, verifiable digital future. It offers a potential pathway to an internet where your data isn't just a liability to be hoarded or a resource to be exploited by others, but instead becomes a powerful asset that you control, that you can share securely on your own terms, and that serves as a trustworthy foundation for the next wave of innovation.
So what does this all mean for you, our listener? As we stand here, really at the cusp of entirely new technological frontiers, the metaverse, AGI, ubiquitous robotics, the principles embodied in Filecoin's architecture, things like transparency, data integrity, and user sovereignty, seem like they'll become even more critical than ever before. So maybe think about your own digital footprint, the vast amount of data you generate every single day. What would it truly mean to own and control the value that data creates? What transformative possibilities could this unleash in your own industry, your community, or even just in your personal life? We leave you with that thought to ponder. We hope you feel more informed and definitely intrigued about this unfolding future of data. Until next time on The Deep Dive.